So today's topic is moment of inertia, and this topic has lot of weightage in IIT, JEE, and CBSE also. So first, I will discuss the important concept like what is moment of inertia. Clear? What is the
Okay.
nature of this quantity? So moment of inertia is similar to like mass, which you have learned in one dimension motion. Okay. In rotation motion,
Yes.
moment of inertia play the same role as the mass. For example, if you are writing F is equal to ma, F is equal to ma. In case of rotational motion, in place of F, you are writing torque, tau. In place of mass, there is a term that is moment of inertia, which is represented by I. Okay. In
Okay.
place of A, we are using alpha, that is angular acceleration. Clear? So, moment of inertia play the same role as the mass. It's not a new term, okay? It's not a new term. It's the same term. They are like mass here, moment of inertia. Moment of inertia. So we are going to discuss in depth regarding this term. So write down the
Sir,
definition of moment of inertia. Write down.
sir, what is
Hello. Yes, alpha. Alpha is angular acceleration. Angular acceleration. Okay.
okay, sir.
Did you watch the video?
Yes, sir.
This is tau is torque. Okay.
Okay.
And I think we have learned this formula also. Tau is equal to R cross F. This is what we have learned. Clear? RF sin theta. In vector form, we have learned like this. RF sin theta. Direction given by the unit vector. Clear?
Okay.
Like this. So today we are going to learn this right on the definition of moment of inertia. Moment of inertia is a physical quantity. Moment of inertia is a physical quantity physical quantity which tell us which tell us about the distribution of mass. Distribution of mass. So if the distribution of mass vary, then moment of inertia also vary.
Okay.
What is the meaning of this? I will explain. Right on. It is a it is a tensor quantity. What is tensor quantity? You will learn in MSc. Okay. It is a
Yes.
tensor quantity like scalar vector. There is one more quantity like tensor. Okay. Tensor
Okay.
quantity. Okay. It is a tensor quantity. Clear?
Yes.
Full stop. It add or subtract means moment of inertia add or subtract like scalar if condition is there like scalar if
Sir, can you please show the previous slide writing?
sure it add like a scalar or subtract like a scalar if the axis remains same. If we will not change the axis, then we can add like a scalar. Clear?
Okay. You can.
If x is write down, it add or subtract like a scalar. If x is remains same. In entire rotational chapter, axis, you will find this term many times. Axis will not leave you. Okay, lot of question. So I think you understand what is the meaning of axis. Axis are a line, straight line that is passing. If nothing is given, always take center of mass. Okay. So
Okay.
about this line, any object is going to rotate. Clear?
Yes.
You know, fan, our fan, like table fan, any fan, it is also rotating about our axis. This is a rod. Clear? And this is our
Yes.
fan like this. So about this axis, this is the axis. Our fan is rotating like this. You know this?
Yes.
Okay. So write down for
Yes.
point mass. Write down the heading for point mass. For point mass. For example, this is the axis. This is the axis. And if you have taken any point mass, perpendicular distance from the axis, this is the perpendicular distance from the axis, r. Then moment of inertia of this point mass about this axis is formula is I is equal to mr square. Mr square. This is the formula for point mass. So remember this m should be inertial mass. Okay. Mass we are saying simply inertial mass because it is inertia. Because of mass there is inertia, so we are saying simply inertia. What is r? Distance of point mass, distance of point mass perpendicular to axis. Perpendicular to axis. Okay. This is
Okay.
point mass. Remember, this is point mass. Next, for body. For example, this is for point mass. If I ask what is the moment of inertia of particular body, body means rigid body. For entire body, then what you will do? For example, this is the body. I'm asking moment of inertia of this. So this is the axis. Okay. You will take a small point mass. This is dm. Okay. Its distance from the axis is r. You are not changing the axis. Okay. Remember, axis remains same. Otherwise, moment of inertia will vary. You will see moment of inertia with respect to axis will vary. This is the point mass I just considered dm on this rigid body, which is at a distance r, perpendicular distance r. Then what is the moment of inertia? Small moment of inertia of this mass multiply square of the distance from the axis. Clear? If you want
Oh,
to find entire body, then you will do the integration. I will be integration. This is for this formula is for what? Whole body. This is the moment of inertia of rigid body, entire body. Moment of inertia of body. Clear?
yes.
Now, moment of inertia of various shapes. I will give you directly. You just remember derivation also I will show you. Don't need to worry. But I want to just give a little bit information regarding you. Write down moment of inertia of some standard shapes. Moment of inertia. Write down the heading of some standard shapes, which you have to learn. Okay.
Oh,
If you learn, then Because in exam, you need to directly write the formula and get the answer. That is the concept. For example,
Okay.
first case is a rod. Okay, rod or bar, like this, the straight rod. And I'm asking a question: what is the moment of inertia of this rod about its center of mass? This is the center. Rod length is L. If the axis, this is the axis, okay,
Okay.
it is at 90 degrees. Remember, it is passing through its center of mass. Okay, it is out of the plane. Okay, this rod is in 2D plane in XY. Then this axis is perpendicular to the rod. Clear? You understand now?
Okay.
Like this, X,
Yes.
Y, we have a rod. Then along Z axis, this Z axis now, can take this plus
Yes.
Z minus Z. This is our axis. Here, rod is placed like this. Okay,
Okay.
this is the center of mass of the rod. So we are asking about this Z axis. What is the moment of inertia? Moment of inertia of this rod about the center of mass. So center of mass, I just take the C. So what is the moment of inertia? Write down the formula about C. If the rod is having the mass capital M, ml square by 12. Okay.
Okay, sir.
ml square by 12 directly you should learn. Okay. Is it okay?
Okay.
Next, moving to the next. Plate.
Sir, one
Right. ml square by 12. Okay. Okay. Next, plate. You know plate? Square plate like
mm,
this. This is the plate. This plate length is, for example, L. Or this is the width of this plate, B. Okay. If I
okay.
ask what is the, for example, its center of mass is this. Okay. If I ask what is the moment of inertia about this axis, like this. It is passing through the axis, but it is perpendicular to this length. Okay.
mm,
About this. See, here about this you can write moment of inertia, the plate having the mass m. About this axis, what is the moment of inertia? M. What is the moment of inertia about this axis? ml square, ml not L. Okay. See, it is like if I ask like about this, it is perpendicular to which axis? L. Okay. You know,
Okay.
it is perpendicular to this. So you will write ml square by 12. Okay. If axis is like that, this is the axis. About this axis, mb square by 12. Okay.
Okay.
For example, now this axis, remember this axis. Here, it is, this axis is parallel to B and perpendicular to L. So that is why I will take this length, ml square by 12, small l. This mb square by 12. Is it clear to you?
Yes.
Okay, this is axis. About this axis, mb square by 12. About this axis, mv square by 12, ml square by 12. Okay. Now
Okay.
for ring, third case for ring. Ring, ring mass is only where? Where is the mass? On the periphery. This is center. Okay. Radius is r. So moment of inertia about the center will be mr square. Center about center means axis passing through the center and perpendicular tips. Okay. It
Okay.
is having the mass. Clear?
No.
4. Disk. Disk has mass over its area. Then about the center, its moment of inertia is mr square by 2. Okay.
Okay.
Here, like if nothing, always remember disk axis perpendicular to its plane and it is passing through center of mass. Okay. 5th. Hollow cylinder. Hollow cylinder moment of inertia is similar to ring. Hollow cylinder. Like this. Clear?
Mm. Yes.
Hollow cylinder axis. This is a hollow cylinder is made up of many rings. So this is the axis. About this axis, moment of inertia is mr square. Okay. Its radius is r. Its moment of inertia is m. Not moment of inertia, mass. Okay.
No.
This is the axis. It is similar to ring. Clear? Hollow cylinder is similar to ring. Clear? For solid cylinder is just like a disc. Solid cylinder. Solid cylinder. Solid cylinder has material inside and in the bulk. Okay, entire bulk material inside. Okay. So it's an
No.
axis. This is the axis. R, mass is m. So about this axis, moment of inertia is mr square by like this. Okay.
Okay.
After this, write down moment of inertia of solid sphere. Actually, my power, I think, 1 minute, 1 minute. Very low power. Okay, Dinesh.
Okay.
Just give me only half hour. Okay, within half hour, power back, or you just wait for half hour.
Okay.
Clear? Because I can't move ahead, otherwise this meeting will be ended, or maybe recording will not be there. Okay.
Okay.
No need to worry. Once power back, I will call you or I will message. You just wait. Okay.
Okay, sir.
Is my screen visible to you?
Ah, yes, sir.
So we have discussed like moment of inertia of solid cylinder. So it is about the axis mr square by 2. It is similar to like this. Now next is solid sphere. Solid sphere.
Okay.
Solid sphere. What is the moment of inertia about its diameter? For example, this is the solid sphere. The center is C. Radius is R. What is the moment of inertia about its diameter? This is the diameter. About this. About moment of inertia about the diameter. 2 by 5 mr square. If m is the mass of solid sphere. Okay.
Okay, sir.
For hollow sphere, next write down. D is diameter, okay? For hollow sphere, for hollow sphere, center C, radius R. So moment of inertia about its diameter 2 by 3 mr. So directly you should remember, okay? Clear? If cube is given like this, cube, cube, some standard shapes like these are the some standard shapes which you must know. This is a cube. This cube is having the length L, side L. Clear? Mass is M. Its moment of inertia about its auntie 100. Yes, auntie are. Hello. Ah. So M is the mass. Clear? M is the mass and L is a side. If you take any side of this cube, clear Dinesh? About any side, about this moment of inertia is 2 by 3 ml square. This is the axis, okay? Ml
Okay.
square. Means cube is there. If you take any side and rotate this cube about this axis, means this axis. So about this axis, moment of inertia is 2 by 3 ml square. Okay? Is it clear? Any
Yes,
doubt?
sir.
This is the moment of inertia which you must know for standard shape. Clear? Now
So,
write one question.
sir,
Write a question. Find
moment of sir,
what?
for both solid sphere and hollow sphere, the moment of inertia will be same or will be different.
Different. Here 2 by 5. For solid it is 2 by 5 and for hollow it is 2 by 3.
Okay, sir.
Okay. Now write one
Okay.
question. We are having the four masses. One mass is here. One mass is here. Okay.
Okay, sir.
And my question is all the masses are at separation A. What is the moment of inertia about this axis? X, X, X. Okay.
Okay, sir.
What is this is the axis about this X axis means X, X. I'm asking you find the moment of inertia about this axis. Name of the axis is X, X. Okay.
Okay, sir.
Is it clear?
Yes, sir.
Now see, simply how many masses are here? X is fixed. This is A by
Four.
2. Okay. It is also A by
Okay, sir.
2. This is A by 2. Clear?
Yes, sir.
So moment of inertia about this XX will be moment of inertia due to this mass, due to this mass, this mass. Okay. So since all the
Okay.
masses are same, so I can write moment of inertia due to this mass. Okay. Multiply 4. Can be write like this. Due to this mass, let's understand. Due to this mass, what is the moment of inertia? M multiply perpendicular distance from the axis. This is a perpendicular distance.
A
Okay.
by 2.
MR square na plus. Due to this mass. Okay.
Okay.
Due to this mass.
Same thing.
I told you it is added like a scalar if axis remains same. This is due to this mass. All are
M
point
into A by
masses. Clear? So what
yes,
is the
sir.
answer? M is square by 4, M is square by 4, M is square, which means 4 times of I. Means M is square by, what is the answer?
4 MA square
Simply M
by
is square.
4.
This is the answer.
Okay.
There.
Yes.
Same question like if I ask one question, next question. Find the moment of inertia. Okay.
Okay.
This is the three mass system. M, M, F. Clear?
Okay.
Like this. Clear? Like this. Equilateral triangle. L, L, 60-degree angle. Question is, find the moment of inertia about this axis. Okay. You can take this A, B, C. So can you solve? Simple. Formula is, these are point masses. Formula is I is equal to MR square. M is point mass multiply perpendicular distance from the axis of rotation. Please tell me, I will be what? This mass is lying on the x-axis. Axis, sorry. So its moment of inertia will be 0. There is no perpendicular distance. For this mass, perpendicular distance is L. Okay.
Okay.
For this mass, perpendicular distance will be this. That will be what? How to find this? This is 60. How much? This is the length now. It will be L cos 60. Okay.
Sir, sir, can you please repeat again?
What? I'm saying, huh? See, this is a triangle. 60. This is the axis. For this mass, perpendicular distance is this. Okay.
Okay, sir.
So how to find? Simply trigonometry. This x, this is also x. This is L. So cos 60 is base by hypotenuse. So x will be L cos 60 half L by 2. So I can write M L by 2 whole square. Clear? ML square plus ML square by 4. So it will be 5 ML square by 4. This is the answer. Okay?
Sir, how that 0 came, sir?
0 for this 0 because this mass is lying on the axis is passing through this mass. Mass is here. Its distance will be 0 now from this axis.
Okay, sir.
Axis lying from this mass, not like this. Axis is passing through this mass.
So then
Clear?
for B it is L square and for P it is M into L by 2 the whole square.
Since mass are equal, na, this is for mass placed at A. This is for mass placed at B. This is for C.
Okay.
Clear?
Yes, yes.
You know, I have taken axis here. But if you have taken an axis, not like this, if I ask you, next question, have you written?
Yes, sir.
If I ask you like, see distribution, I already told. This moment of inertia is a term that depends on the axis. Okay, if you change the distribution of mass, means if you change the axis, then moment of inertia value will also change. If I ask like
Okay.
same question, mass is here, three masses. In this question, like same thing, like this is L, L, L. Okay.
Okay.
Now here, our axis is passing like this. Okay. It is
Okay.
perpendicular. Then again, if I ask what is the moment of inertia about this axis, in previous case, it is like that. It is lying in the same plane. Now I'm asking, this is our axis, y, y. Okay.
Okay.
So how to find simply I, y, y. Due to this mass, 0. Due to this mass, this L will be perpendicular. Okay.
Okay.
For this mass, this L will be perpendicular. So answer is 2 ml square. Clear? Meaning is what? If x is like this, y is like this. If I take any axis which is perpendicular to x and y, okay, then
Okay.
all the distance, this is L, is always perpendicular to this axis. Clear?
Okay. Yes, sir.
Any doubt?
No, sir.
So answer is 2 ml square. Any doubt like?
No, sir.
So these are the basic question, like if you have clarity regarding this. Now, you know, nowadays these questions they are asking. Okay. For if
Okay.
you want to solve for entire rigid body, already I have explained like this. If this is the 1 minute, if this is the any rigid body, okay,
Okay.
and axis is like this, rigid body, then you will take a small mass dm, which is at a distance r. Here
Okay, sir.
there will be many masses. Okay, there will be many masses dm. It is at different distance, different perpendicular distance. Okay, then what we will do? We will take a moment of inertia due to small mass em r square. Then we will do the integration. Clear? Integration di will be I. This is the formula for what? Find the moment of inertia of rigid body, entire body. Okay, whole body.
Okay.
This is what this I you have solved. Na? This I is for whole body. Clear?
Yes, sir.
Now I will discuss the application of this. Before that, like 1 minute. Write down. I think I should discuss the application of this. I will share one slide. 1 minute. Then I will discuss perpendicular axis theorem.
Okay.
I think I should discuss 1 minute. First, we will discuss perpendicular axis theorem. Okay.
Okay, sir.
Then I think we should proceed for one some slides. That is easy only. So write down perpendicular axis theorem. Basic theorem. Write down perpendicular perpendicular axis theorem. Clear? So it is very easy.
Yes.
Like if I ask, like perpendicular means if two axes are parallel, not parallel, perpendicular. It is valid for 2D, where you should apply in lamina, like lamina means sheet, where you should apply this 2D body, 2D body, two dimension. Okay.
Okay, sir.
Example, lamina, plate. Lamina means plate. Thin sheet, ring, disc, lamina, thin sheet. Here you should apply this. Clear? So,
Yes, sir.
condition. What is the condition? For example, this is the any body. Okay.
Okay.
And xy, if I draw the xy, if this is the, if I draw xy like this x and y. Okay. Xy lie in the same plane. Or this is the z. Xy lie in the same plane. Okay.
Okay.
Y. Clear?
Yes, sir.
If I take any point mass dm, which is at a distance r. Okay.
Okay.
This is x. This is y. So, what is the moment of inertia of this small? If I ask, like, what is the moment of inertia of this point mass about x-axis? About x-axis means if my axis of rotation is x, how will you write? dm, perpendicular distance from the axis. How much? Y. Clear?
Yes, sir.
Similarly, moment of inertia about y-axis is what? Point mass multiply perpendicular distance from the axis. What axis? Y. That is x square. Clear?
Yes, sir.
If I ask moment of inertia about z-axis, so it will be what? dm multiply r square. Is it so? Clear?
Yes, sir.
Clear? So
Yes, sir.
r square, if I ask you, this is origin x, this is y, z is like this. Okay. This is
Okay.
the dm mass. This is y, x and this is y. Then r. It's 90. Okay. X, y. 90. Can I write like this? R square is equal to x square plus y square. Can we
Yes,
write?
sir.
Pythagoras theorem.
Yes, sir.
So I can write like dm r square is x square plus y square. Clear? And if I ask like dm iz, how can you write like this? dm, sorry, d iz is dm x square plus y square. Okay. So moment of inertia about z axis is what? dm x square plus dmy square. Or what is dmx square? If you look at this, this is the moment of inertia about x-axis. Clear?
Okay.
So diz equal what? Dix plus diy. If you do the integration, both side, this is called Iz. Moment of inertia about z axis is equal to about x plus about y. This is the perpendicular axis theorem. If you know moment of inertia about x, about y, then you can find about z. Condition is that z is perpendicular to x and y both.
Okay.
Clear? Now, when you are going, when you will apply this theorem, condition is there. Condition, write down the condition when this theorem is applicable. Condition is there. First, x comma y and z should be mutually perpendicular. Should be mutually perpendicular. Then only you can apply. Okay.
Okay.
Next, x and y axis. X and y axis must lie in the same plane. You can check. I have drawn in the same plane. Okay.
Okay.
Should be. These are the observation. Okay. Should be in the plane of body. The plane of body. Third, z axis. Z should be perpendicular to plane of body. Z will not lie in the same plane. Okay. Z should be perpendicular to plane of body. Meaning is that. Okay.
Okay.
So if you take any body, any rigid body, for example, ring,
I'm
ring,
waiting to see.
center, 1 minute. Okay. This is one axis, x axis, y axis. Clear?
Okay.
Y, you can say this axis. About y axis, about x axis. There are two axes. You can see x or y lie in the same plane of the body. Okay. And the z axis will lie perpendicular to them. This is z axis. Okay.
Okay.
Then we can apply the perpendicular axis theorem. Iz equal ix plus iy. Okay. Have you done this?
So previous
Class will be very short. Actually, I will discuss two important things only. Okay.
the condition for perpendicular axis theorem.
Condition, yeah.
That's
Right.
like
X, Y, and Z should be mutually perpendicular.
okay.
Actually, I have to go for tomorrow. I have to institute actually. So I have to do preparation. So I will discuss next is parallel axis theorem. Then I will finish this lecture because content is delivered. Now, in the next class, I will discuss some derivation and numericals only. Then this topic is finished.
Okay.
Because most of the important section I have discussed in morning only. That is important. Okay. Parallel axis
Okay.
theorem, write down. This is very important. Like parallel axis application, I will discuss later. Okay. Parallel axis theorem. Parallel axis theorem. From the name itself, you can understand this theorem we need to apply only when two axes are parallel. There,
Okay.
for example, if this is the body, okay, and You need to find the moment of inertia about this axis, which I am drawing here. Let us suppose the moment of inertia about this axis is I. I need to find this value I. Then condition is there. You should know the moment of inertia about the center of mass. You should draw the axis parallel to this. It is passing through the center of mass. These two, these two must be parallel. Okay. And the distance between, let us suppose the distance between these two parallel lines is A. Clear?
Okay.
Moment of inertia about the center of mass is ICOM. And M is the mass of this body. And if you take, even if you take a point mass, if you take a point mass, which is at a distance R. Clear?
Yes.
Then if I ask like what is the moment of inertia of this point mass about the center of mass, you will write like this. Clear? Similarly, if I ask what is the moment of inertia of this point mass about this axis, dm r plus a whole square. Clear?
Okay.
So how will you write? If you open this a plus b whole square, it will be like this: a square plus b square plus 2ar. So you can write like this: di will be what? Dm r square plus dm a square plus dm r into a. Clear? And
Yes.
if I ask you like what is dm r square, it is what? DICOM. This is what? dm dma square. Clear? It is, I think I forget to. Okay. So how will you
Okay.
write? Di will be what? DICOM plus. You know, this A always remain constant because two lines are parallel. So A is constant. I can take outside. Okay. I can
Okay.
write like this plus 2A way RDM. If I integrate both sides like this, then if I ask you what is the value of integration RDM? If this is I, this ICOM, integration DM is M, like, and the value of this will be 0. I will tell why.
Okay.
This is the moment of inertia. Parallax theorem. Final theorem. You should remember this. Meaning is that, you know, RCOM. How will you write R? I think you are familiar. Not this integration RDM. If you divide and multiply by, okay,
Okay.
then what is this? This is what? What is this? RCOM. Okay, position vector of center of mass. Clear? You know, you have learned this.
Yes, sir.
Since I have taken origin, position of center of mass is at origin. So I can take this 0. But every time it is not 0. Clear? Here I have taken in this
Okay.
derivation like I have taken center of mass is at origin. That is why this term, this term going to be 0. Okay?
Okay.
So remember one thing, every time it is not zero, this theorem is valid only when condition is there, two axes must be parallel. Write down the condition. I is equal to ICOM plus MA square. This theorem condition is very important condition. One of the axes must passes through the center of mass. Then only you can apply, because then only that integral term is zero. Two axes must be parallel. You can write two axes conditions there. Two axes must be parallel. Second, one axis must pass through origin. Not origin, must pass through center of mass. One of the axes must pass through center of mass. Clear? Third, A is what? You know what I have drawn like this A? A is what here in the above equation? A is what? Perpendicular distance between the two axes. Perpendicular distance between two axes. Clear?
Yes, sir.
Meaning is what? For example, if you want to apply this theorem, then two axes must be parallel. If you take one axis like this, then one axis must pass it through the center of mass. If you want this moment of inertia I, then you should apply I is equal to ICOM plus M, mass of this body, multiply perpendicular distance between the two axes, square of that. So I will be what? ICOM plus M into square of the perpendicular distance between the two. It remain constant, okay? Perpendicular. And you
Sir,
must
can
know
you
what is the moment of inertia about the center of mass. Then only you can apply this thing.
okay.
Clear?
Sir, can you show the conditions for parallel axis theorem?
Very important, like. Clear?
Okay.
So I will finish this lecture, and tomorrow I will discuss in the next class. Whenever we have next class, I will discuss the application of perpendicular axis. Lot of question I am having. Today I am not going to
Okay.
discuss because you need time to digest this much content. Clear? Otherwise, things
Okay.
will be little bit in trouble. You learn whatever you have learned today morning to till evening, whatever you have learned, whatever I explained. These are very, very important derivation and concept. Clear? You should have a clarity of these. Okay?
Okay.
This is what we have discussed. Okay? Moment of inertia. So, Dinesh, if you have any doubt, you can ask me anytime. So, I will stop this lecture here.
Okay, sir.
So, maybe we have a next class on coming Thursday or Wednesday. I will tell you. Okay?
Okay.
Thank you so much, Dinesh.
Thank you, sir. Good night.